Welcome back to the workshop. So we took the car out to Phillip Island the other weekend for a bit of a track day due to a lack of tarmac rallies available to us at the moment, and we had a pretty good day, except I kind of sort of broke the gear shifter. It wasn't terminal, and with a bit of MacGyvering we got ourselves back in the action, but I managed to snap off the reverse lockout. We've got a 6-speed box, so there's a lockout to stop you going into reverse instead of 6th. So I found as I was coming onto the main straight, I couldn't go into 5th gear. I thought, ooh, something wrong with the gearbox here, and then realised, oh, hold on, I'm pulling the gear shifter over further than normal. 5th gear was indeed still there, and I could get 6th, but it was a little bit terrifying because there was nothing stopping me going into reverse. So we need to fix that, and I reckon this might do it. So here's the offending part. It's the matching gear shifter to the gearbox that we're running. So this is an alfa part. Look, it's probably good enough for running down to the shops, but clearly not strong enough for the heat of battle. So we need to do something about it. I could just buy another one and then reinforce the fence that we use for the reverse lockout. But this is another piece that I've got, and you can see it's cracked down on through this hole. This is where the arm pivots on for the cross gate of the gearbox. So clearly these things are on the limit. Don't want to keep mucking around with plastic, so let's try and machine one out of this enormous block of aluminium. It looks like a fairly complicated part, but really when you break it down, it's just 3 mounting holes, a pivot for the cross gate lever, and then this spherical area for the gear shifter to roll around in. The spherical portion is an issue. There's no way I can machine that with the tools that I've got. So what I'm planning on doing is carefully removing this section of the plastic case out, leaving us with a sort of a cupped washer that we can press up inside our newly machined aluminium housing to retain that spherical rotation. So I think the first job is to try and liberate that part from its surrounding material. Well, that was a massive fuck around, totally my own doing. Haven't used the mill for a while and thought I should redo one of my favourite tricks of completely forgetting to minus half the cutter from the cut. So I machined the spigot too thin. Had to turn it around and do it from the other end. Great. Anyway, this strangely shaped spigot should fit this strangely shaped hole. And I've spent a fair bit of time making sure it's all centered. So this spigot should be centered to this ring here, this machined outer ring, which I have clocked up in the trusty 4-jaw. I'm assuming that this strangely shaped hole is in fact in the center of our soon to become spherical spacer. So hopefully this will just fit on. I want it to be a nice tight fit. It is indeed a tight fit. Ooh. Come on, come on. Did fit. Sure it fitted. That is a tight fit. Come on. Gotcha. All right. And I had a washer here somewhere. So this should be the easy bit. Famous last words. meant to happen. It's like I bought one. So now we can start actually making the block to house all this stuff. Time to finally turn our attention to this big block of aluminium. First thing I'm going to do is machine out the centre for the shifter and our newly created spherical bushings. The centre line of the shifter to the pivot point for the crossgate change is a fairly critical dimension. Needs to be 34.85. But they run perpendicular to each other in the block, and I can't come up with any crazy way of working that out on the DRO, so I'm going to have to rely on some ninja marking out skills. Should be fine. So that's marking out the centre line of where we want the shifter to go. So the shifter hole will go through that plane, and then we want 34.85 from that up. Okay, and we don't want this to be in the middle of the block either. One moment. Okay, just consulted with the design office, and we want the center line of the shifter to be 31 millimeters off this face. So we'll zero that one out. To the lathe. So we are back at the mill. Don't know where I left off. Battery went flat in the camera and I mowed it on through on the lathe, but we've done all the round stuff on the lathe, and now it's time to do some square stuff on the mill. I think I mentioned before that I couldn't work out any good way of positioning the crossgate arm to the center hole for the gear stick, or the center of the gear stick hole. Scratch that. I've got to cut a slot in here for the arm to go through, so I can. I've centered this hole, the gear shifter hole, in the mill on the DRO, so I can cut a slot through here with the end mill, and then I can spin the block around, use that slot as a datum, and then carry on from there with the DRO. So that was a lot of talking. Just cut a slot. Where are my safety glasses? Okay, the moment of truth. The position of this pivot point can make or break this part. I mean, there's a million ways I can destroy the part after this, but for now, this is the moment of truth. I know I scared a lot of you in the last video, so don't worry, I've got the tried and true blue safety beer there, because this is a dangerous bloody operation and it's going to require some additional safety. Let's drill this hole. Got a lot of the functional features in. Time to start chiseling out the shape. And the first thing I want to attack is getting our little reverse gate sorted. So I need to remove a substantial amount of material. My mill is tiny. For reference, that's a 3mm drill bit. So I'm going to head over to the bandsaw for approximately 11.5 hours and remove as many big chunks on the saw as I can. Back from some bandsaw magic. Time to make that a nice, pretty machine surface. Still got a fair bit of material to remove. I gave myself at least 5mm on all dimensions because the bandsaw is not the most accurate tool in the world. 12mm cutter, about as big as I can go in this machine. Time to create a mess. We are slowly hacking away at the piece. Next operation is to create a pocket. The pivot arm of the crossgate lever isn't the full length of the block, so we need to drop this face down, and then we'll move over to the lathe and machine up some nice little bronze bushes for the pivot arm. But first, more swarf. Time to make a couple of bronze bushes for that pivot arm. 16mm OD and a 12mm ID for a 12mm pivot rod. Normally I would drill that out to 11, which I've done, and then just throw a reamer through. It's 12mm. Unfortunately I didn't have a 12mm reamer, so I got on eBay and I ordered a 14mm reamer, and I still don't have a 12mm reamer. I got confused that the plastic part's got 14mm bearings in it, and I was thinking about reusing the bearings, and I decided I'd make some bronze bushes. Anyway, here we are without a reamer, so I'm going to attempt to machine to size with a tiny little boring bar. This may not work. If it doesn't, I'll order the reamer and just make up a couple of new bushes later on. Hardest thing about doing this is measuring it. Let me get you caught up. Got our billet shifter housing that is rapidly reducing in mass. This is the spherical spacer that we machined out of the old shifter housing that slides in. That's got no way to rotate it rotationally, so I've put a small grub screw in the back there. Our shifter goes in like that, then the original spacer, and it's an O-ring that sits in there. Bronze bushes worked really well, even though we didn't have the required reamer, so I'll press in there and I'll Loctite those in. And that slides in like that. And that's just got a little circlip that holds it all together. I've drilled one mounting hole, and I've actually drilled and tapped a couple of holes that I can get through from the bottom while we've still got this lump of aluminium in to locate it all. And we are starting to look like a shifter. So the reason I've left this large mass of material at this end is I want to add an additional feature that wasn't on the original shifter mount. The detent or centralisation springs for the gearbox are all at the gearbox end. So the spring force has to go through quite a few linkages and through the cables to get to the gear shifter, by which time it's a pretty weak centralisation force. I think that might have been one of the reasons why I was putting so much force into this little gate, because I wanted to really make sure I was in fifth and not in third. So I want to add an additional spring, detent spring, onto the shifter end as well. I did order one. It hasn't shown up. it's Boxing Day. I want to keep going on with this, so I made up something. Where did it go? I made up this contraption and unwound a coil spring I had that was about the right diameter to get myself some spring steel, and made up this little detent spring. Before I show you how this works, or how I hope it's going to work, I'll just do a quick demo and show you with some welding wire how I use this to create this little torsion spring. So this is how this crazy contraption works. This is our bit of welding rod pretending to be some spring steel. I've got a bolt with a hole sort of half drill, half milled into it. That will hold our bit of wire in the appropriate location. And now we just turn the lathe on as fast as it can go. Only kidding. So then it's just a matter of obviously this spring steel put up a bit more of a fight, so there's quite a bit of swearing, and that's why I'm demoing this on a bit of welding wire instead of the actual product. Back from my trip to the mill, you've seen the spring, and I stopped off on the way at the lathe and turned up this little top hat. That will centralise the spring, and we will drill and tap an M6 into the shifter block. So hopefully you get some idea of how this is going to work. So this spring can now actuate the gear shifter back to centre in both directions. Looking good. We have gears. Well, most of them, as predicted. I can't get into fifth because the lockout's a little bit too wide. So I've marked off where I need to chew some material away for that. The detent already feels a little bit better than it used to, but we'll carry on with our additional spring. So I've added it in there. That's in third to make sure we've got clearance. And then I'm just measured from this side to the centre. Okay, time for some assembly. It's 6 o'clock in the morning, so safety coffee time at the moment. We have our finished aluminium block. Quite happy with how that's turned out. Let's put it together. Up our grub screw. Got a little bit of rubber grease here for our plastic ball. Whoa! Yesterday I Loctited our bronze bushes in. You can see the original one has these needle roller bearings, which is an odd choice for something of such low speed. I think the bronze bushes are a better option. They also give a bit of thrust bearing surface, whereas in the original unit the thrust was just taken by this steel insert. So they had steel on steel, which is generally not the greatest idea. Just chuck a little bit of grease on that. Probably doesn't really need it, but can't hurt. Right. That's all operating as expected. Now for our additional detent spring. There's been a couple of changes. So this is the prototype spring and its corresponding block. I managed to find a hobby shop with some proper spring steel, slightly bigger diameter, and made up another spring that's come up very nicely, and also machined up a new spacer block. And you can see we've got considerable centering action now. I reckon that's going to work out very nicely. Let's throw it in the car. And she's in. All went in nicely, and we have all the required gears. Even reverse. And some epically good centralisation. That deserves a beer. Thanks for watching.